All right, so for those of you all who are interested in the past paper proofs, trigonometric proofs, 2011 was done in the last video. We're going to do from 2012 straight up the road to 2021. Between 2018 and 2019, that's when the structure kind of changed. And I don't think for 2020 we had a paper 2. So yeah, we'll be doing all of these proofs. Some of them are not proofs per se, but calculations. Like for this one, for example, I have to find what tan of pi on 12 is. This one, I'll have to calculate tan of 2m. And all the others, proofs 2013, I have to find alpha if alpha is acute. So we'll go through all of them. If you all have any requests for any particular question or particular year that you all would like me to complete, just leave it in the comment section. So let's go. We'll start off with 2012. So we are required to prove RTP that 1 over sec theta plus tan theta is equal to 1 minus sine theta over cosine theta, followed by proof. And we will be taking, in this case, it doesn't matter which side I take. To me, both sides are equally as complicated. But I have more to do with the left-hand side because I have an identity for sec and I have a couple identities for tan. So taking the left-hand side, I can say, well, I'll write down what the left-hand side is before I hit my recall. 1 over sec theta plus tan theta. I'll recall that sec theta is 1 over cosine theta and tan theta is sine theta over cosine theta. Now my denominator becomes a little bit complicated now. So I have 1 over sec theta, 1 over cos theta, plus sine theta over cos theta. The denominators on my denominator are the same thing. So if I just consider my denominator alone, my denominator will be 1 plus sine theta all over cosine theta. Now, some of you all might see it, some of you all might not. For those of you who might not, this is the exact same thing as 1 divided by 1 plus sine theta all over cosine theta. And when we are dividing by a fraction, we must invert and multiply. So this becomes 1 multiplied by cosine theta over 1 plus sine theta, which is cosine theta over 1 plus sine theta. But if I look at my right hand side, it's not looking kind of weird. So you might be, for those of you who don't probably fully understand, you might be encouraged to kind of ratchet something. But I'll say as soon as you start ratcheting something in proofs, you're going on the wrong road. So look at what we have. We make no mistakes. Look at what we want. I want a cosine theta on the denominator, and I want a 1 minus sine theta on the numerator. Now, if I remember correctly, in the last video, when we did 2011 proof, we did say that we can multiply by the number 1, and the number 1 takes many forms. And it's for us to decide, well, what is going to be this number 1 that I'm going to be multiplying by? One could be cosine theta over cosine theta, sine theta over sine theta, 1 plus sine theta over 1 plus sine theta, if I wanted. it have a couple ways we can approach this one here. It mightn't be clear cut, but we can multiply by cosine theta over cosine theta. To make life even easier, I want 1 minus sine theta on the numerator. So I'll multiply by 1 minus sine theta over 1 minus sine theta. That way, I get a 1 minus sine theta on the numerator. Or I can multiply by cosine theta over cosine theta, and that way I get a cosine theta on the denominator. So by multiplying by 1 in either of these forms, I get a piece of my numerator or a piece of my denominator. So if I wanted, I'll do one case and then I'll do the next case. I can multiply by, increase this, by cosine theta over cosine theta. This way, I end up with a cosine theta on the denominator. Well, if I multiply by 1, this becomes cosine squared theta over 1 plus sine theta multiplied by cosine theta. Now, I could hit a recall here because I end up making it a little more complicated in order to make some form of a substitution. So I'll recall cosine squared theta plus sine squared theta is 1. So cosine squared theta is 1 minus sine squared theta. Every single time when I rearrange this identity, I will end up with a difference of 2 squares. All the time. I'll end up with a difference of 2 squares. This is 1 squared minus sine theta all squared. This is a difference of 2 squares. And this is 1 minus sine theta into 1 plus sine theta. So cosine squared theta is also equal to this. So I end up with cosine squared theta, which is 1 minus sine theta into 1 plus sine theta divided by 1 plus sine theta cosine theta. 1 plus sine cancels with the 1 plus sine. And I end up with 1 minus sine theta over cosine theta, which is the right hand side, QED. That's 1. Or I can take another approach. I can multiply by 1 plus sine theta over 1 plus sine theta. So instead, follow it this with me. I'll multiply by 1 plus sine theta over 1 plus sine theta. So I'll end up with cosine theta into 1 plus sine theta over 1 plus sine theta into 1 plus sine theta. The denominator now is 1 plus sine theta all squared. So this is equal to cosine theta into 1 plus sine theta over 1 plus sine theta all squared. I can expand the denominator if I want to. So let me do it now. We're going to need some more space, so just follow with the colors. This is cosine theta. I'll expand it up. Yeah, let me leave it like that for now. 1 plus sine theta over, oh no, my bad, I have to multiply by 1 minus sine theta because it's 1 minus sine theta I am looking for on the numerator. Minus, plus, minus. Good. Makes life a lot easier now. The denominator now becomes my difference of 2 squares. I end up with cosine theta into 1 minus sine theta over, this here becomes 1 squared minus sine theta squared cosine theta into 1 minus sine theta over 1 minus sine squared theta, you'll have to recall the same things you recalled in the orange over here. But 1 minus sine squared theta is cosine squared theta from this line. But you'll have to recall it. So this becomes cosine theta into 1 minus sine theta over cosine squared theta. Cosine cancels with one of the cosines. I get cos theta, which is 1 minus sine theta over cosine theta. QED. Perfect. So let's go on to 2013. 2013 was not a proof, but a calculation. So go in your past papers and check it out. I most believe the question said, if tan of theta minus alpha is equal to a half and tan theta is equal to 3, use an appropriate compound angle formula to find out alpha if alpha is acute. So this is a compound angle formula. So let me see what we can do here. So firstly, I will recall, I'm going to put this in green. So we go color coordinate the years now. I'll recall my compound angle formula for tan of theta minus alpha. A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Let me double check that. Usually you'll find it in your formula sheet at the beginning of your exam. So I really don't want you to depend on a formula sheet, but I mean the data use. Yes, so for tan, the minus sign will correspond to the minus sign on top. The plus sign will correspond to the plus sign on top. So for example, tan of A plus B is tan A plus tan B over 1 minus tan A tan B. Cool. So plus minus plus. Right. So therefore, tan theta minus alpha will be tan theta minus tan alpha all over 1 plus tan theta tan theta tan alpha. Now remember, tan theta is 3. So I have 3 minus tan alpha over 1 plus 3 tan alpha theta. And from the information, this fella is equal to a half. It's just a simple cross multiplication now. I end up at 1 plus 3 tan alpha is equal to 2 into 3 minus tan of alpha. Rearrange again. We'll expand first. 6 minus 2 tan alpha, 3 tan alpha plus 2 tan alpha is 6 minus 1. 5 tan alpha is 5 and tan alpha is 1. Now the question did say that find theta and theta is acute, but generally we know tan is positive. My solutions will lie all school teachers. So my principal value is tan inverse of 1, which is 45 degrees. If you're unsure whether you have to work in degrees or radians for this question, you can work in either. The question didn't give us no indication that alpha is in degrees or radians. So work in either. Theta is my principal value, which is 45 degrees. Theta is 180 plus the principal value, 180 plus 45 degrees, which is not acute. So therefore, y point theta, alpha is what we're trying to find out. So therefore, alpha is 45 degrees, or pi on 4. 180 divided by 45 is what? Pi on 4. Good. Radians. All right. 2014, another proof. Although the proofs might be all over the place, all you have to do is follow. Following any proofs could make life real easy. Cool. Hopefully, yeah, this is easily seen. All right, so the proofs are color coordinated, and I'm just doing this to save space, although I don't have to. Nice. So again, RTP followed by proof, and I'll take the left hand side in this case again. So taking the left hand side, we have tan theta sine theta over, oh good lord, over 1 minus cosine theta 1 plus 1 over cosine theta. So I recall that tan theta is sine theta over cosine theta. So look at my numerator. My numerator becomes sine theta over cosine theta multiplied by sine theta all over 1 minus cosine theta. I'm going to fix up my numerator a little bit. Sine squared theta over cosine theta, watch, divided by 1 minus cosine theta. Sine squared theta over cosine theta multiplied by 1 over 1 minus cosine theta, and this becomes sine squared theta over cosine theta into 1 minus cosine theta. This is a similar instance like the orange up here, when you had to rearrange and try and make a difference of 2 squares. Now, I'm not stuck. I have a recollection I can make for sine squared theta. So I'm not going to multiply by 1 as yet. So I recall that sine squared theta plus cos squared theta is 1. Sine squared theta is 1 minus cosine squared theta, which is 1 squared minus cosine theta squared. It's a difference of 2 squares. I get 1 minus cosine theta into 1 plus cosine theta. So now this turns out to be 1 minus cosine theta into 1 plus cosine theta all over cosine theta into 1 minus cosine theta. You cancel with you. 1 plus cosine theta over cosine theta. I have a single denominator and multiple numerators. I can split up the fraction as each numerator over that common denominator. So this is 1 over cosine theta plus cosine theta over cosine theta, 1 over cosine theta plus 1. Don't say it's equal to the right hand side as yet, because the right hand side is 1 plus 1 over cos. So just rearrange it first now. It's the right hand side, QED. This one was a simple one. This was what, 2014. Right, let me tackle 2015 now. I do this one in blue. All right, so I mean, let good sense prevail. taking the left hand side. Now in the left hand side, I'm seeing a couple compound angle, double angle formulas. So that the only substitution I see I can make here. So I have sine theta plus sine 2 theta all over 1 plus cosine theta plus cosine 2 theta. Now remember, for sine 2 theta, this is 2 sine theta cosine theta. And cos 2 theta is cos squared theta minus sine squared theta. We have three identities for this here. The next one is 2 cos squared theta minus 1 and 1 minus 2 sine squared theta. Now, which one of these will I substitute? That comes down to practice. I mean, if you substitute any one of them, you'll just have to make another substitution to get to where you're going. But sometimes it cuts time down by about a couple minutes, 1 minute or two, which is plenty in an exam, if you substitute the correct thing. So let me see. I'll continue the proof on top. Sine theta plus 2 sine theta cosine theta all over 1 plus cosine theta plus. Now what are you going to substitute here? Let me try a thing. I'm going to try and substitute my identity in terms of cosines only. So plus 2 cosine squared theta minus 1. If I'm stuck and I have no more substitutions, I'll make a substitution for cos squared theta. Now, I can do something on the numerator. I can factorize it. This is 2 open bracket 1 plus 2 cosine theta. Sorry, sine theta. My bad. All over. Now, seeing something happening here. In the back of my mind, I know tan theta is sine theta over cosine theta. So, if I have a sine theta on top, I want to have a cosine theta on the denominator. So, somehow or the other, the denominator will have to do some work and get a cosine theta alone on the denominator. So, let me expand this here. I can expand this in my brain. This becomes 2 cosine squared theta. This 1 cancels out with this one. 1 minus 1 is 0. Plus cosine theta, which can be factorized. I have sine theta into 1 plus 2 cosine theta over cosine theta into 2 cosine theta plus 1. Now, you can cancel this here. Both of these are the same thing. You don't have to show it as previous over here. You don't have to show it because we're doing a cancellation. And brother man, I'll hit them with my last recall. And I'll say tan theta is sine theta over cosine theta. So this turns out to tan theta, which is my right hand side. QED. Alright, 2016 now. Another proof. Let me do this one. I'll purple. No, we do it purple already. So let me mix up the color a little bit. Alright, I like green. Alright, again, I'll take the left hand side. Taking the left hand side, I have sine theta plus alpha over cosine theta cosine alpha. Now this is tan theta plus tan alpha on the right hand side. as in a compound angle formula is the only thing I can do here. So I'll recall sine of A plus B is sine A sine B plus, no, sine A cos B plus cos A sine B. So I have sine theta plus alpha over cosine theta cosine alpha, alpha here, is equal to sine theta cosine alpha plus cos theta sine alpha all over cos theta cos alpha. Now, my numerator and my denominator is something similar to the case where we split up this fraction. I have one single term on the denominator, which is cos theta cos alpha. I can break this up into two separate fractions. So my first fraction is going to be sine theta cos alpha all over cos theta cos alpha plus cos theta sine alpha over cos theta cos alpha. Cos alpha cancels with cos alpha, cos theta cancels with cos theta. I'll recall that sine theta over cos theta is tan theta. So my identity turns into tan theta plus tan alpha, which is the right hand side, QED. Right, I'm sure I could squeeze up 2017 on this side. Right, let me pick another color. Yeah. Again, taking the left hand side. 1 minus cos squared theta over 1 plus sine theta. You could see what substitution to make here one time. Cos squared theta. So I'll recall cosine squared theta plus sine squared theta is 1. So cosine squared theta is 1 minus sine squared theta. 1 squared minus sine theta squared. You have to state it's a difference of two squares, guys. Difference of two squares. And 1 minus sine theta into 1 plus sine theta. Now you might ask yourself, so how come we know we had to change it in this format? Why we just couldn't leave it as 1 minus sine squared theta? Whenever you're doing your work, try to be one step ahead of what you're doing in your brain. So I am writing down the identity for cos squared theta, but I am one step ahead of that step in my brain. So if this is step 1, in my brain I'm in step 2. I know that 1 minus sine squared theta not going to cancel with anything on the denominator. So I want to try and simplify my identity as much as possible. So I'm looking for a cancellation or a substitution to make life easy. The substitution in this case that will make life easy wouldn't be the 1 minus sine squared theta. It'll be the 1 minus sine theta into 1 plus sine theta. But it's always good to just write down this identity here in its full form, straight down to the difference of two squares, just in case you need it. So I end up with 1 plus 1 minus sine theta into 1 plus sine theta over 1 plus sine theta. You cancel with you. I end up with 1 plus 1 minus sine theta. Oh shucks, is not that. My bad, is 1 minus all of that. So my identity is 1 minus sine theta into 1 plus sine theta all over 1 plus sine theta. You cancel with you. I get 1 minus 1 plus sine theta, which is sine theta, which is the right hand side, QED. So just like I make that little mistake and I put a plus there, just be on the lookout. All right, mistakes does happen, so it's always good to be thinking. Be always thinking. Don't just do things like a robot. Always think. So we'll do 2018, then the specimen paper 2018, 2019, and 2021. All right, so 2018. Do this one in normal block. Both sides you could make substitutions with, but to me the left hand side still looks more complicated. Remember, required to prove followed by proof. Taking the left hand side, 1 over 1 minus sine x minus 1 over 1 plus sine x. Now, I think in one of the videos on my channel, I showed the shortcut for adding or subtracting any two fractions. So if I have a over b and there's a fraction plus x over y as a next fraction, one way we can figure out what this is equal to is by getting the LCM and doing a long time thing. But instead, you can multiply across this way, that's ay plus the operation remains the same, multiply across this way, bx all over multiply across this way, by. For example, a half plus 2/3. Multiply across this way, 1 by 3 is 3. Multiply across this way, 2 by 2 is 4. And multiply by across this way, which is 6. And this is 7 over 6. If we check, a half plus 2/3 is 1 and 1/6. Another example, 7 over 3 minus 4 over 5. Multiply this way, 35. Multiply this way, 12. Multiply this way, 15. 35 minus 12 is 23 over 15. So again, 7 over 3 minus 4 over 5 is 1 and 8 over 15, which is 23 over 15. I'm going to extend the same courtesy, so there's two fractions on this side, because I have, that is one denominator, but the denominator just have two terms in it. So I'll multiply this way. I have 1 multiplied by 1 plus sine x, take away, I multiply this way, 1 minus sine x. Now I'm not going to put the 1 here and the 1 here because it's understood. All over, multiply the two denominators together, 1 minus sine x into 1 plus sine x. Now, you're supposed to be seeing something here. The denominator, it looking like a difference of 2 squares. It looking so. So I'll kind of simplify my numerator. I'll rub off all of this because I'll go have that in the recording. This is equal to 1 plus sine x minus 1 plus sine x all over. I'll come in my working column and I'll state 1 minus sine x into 1 plus sine x is a difference of 2 squares and that is 1 squared minus sine x squared, which is 1 minus sine squared x. 1 minus sine squared x. This is 1 minus 1 is 0, so I get 2 sine x over 1 minus sine squared x. I'll recall. Now, I'm not going to multiply by anything because I still have a substitution I can do. Recall that sine squared x plus cos squared x is 1. So cos squared x is 1 minus sine squared x. So my denominator is actually cos squared x. So this becomes 2 sine x over 1 minus, cos squared x. And there's our next little trick. This is 2 sine x over cosine x multiplied by cosine x, which is 2 sine x over cosine x multiplied by 1 over cosine x. Is multiplication. So I'll recall, please know the difference splitting up a fraction when it's addition, subtraction, or multiplication. Please know the difference. Sine x over cosine x is equal to tan x. So my identity turns into 2 tan x multiplied by 1 over cos x, which is 2 tan x over cos x, which is the right hand side, QED.